So you got 2 online homework due on this coming Monday by midnight, 11:59, P1 and P2. So if there's only mostly 2 sections a week that you guys have to do. So please make sure you guys start working on P1 and P2. P1 is a bit easier, P2 is a bit hard. So I do have a question. I do have students asking me about these P1 questions that I will share it to you guys, and we will go to that. So the class starts now. So I will later on I'll ask for attendance. So right now we just concentrate on your homework here. So this is question 17. This is the one that a lot of students have questions with, that they doesn't know how to do the work here. So I'm gonna teach you how to do this question number 17. So this question is asking us to evaluate the expression absolute value of x minus 2 divided by x minus 2. And then they got these 3 choices here. So I'm going to teach you how to do this kind of questions. So when you guys do online, you know how to do it. So what is really important for this question 17 on P1 here is your denominator. Your denominator is, yes, you guys know that we cannot make it equals to 0. So, so what happened is that we try to solve the denominator. So as you know, the denominator here is x minus 2. So you make it equal to 0 and you solve it. So x equals to 2. So this x equals to 2 will put inside this. This is how they figure out the 2 here. Is they figure out, this is called what we call as a domain restrictions here. You will learn that in college algebra. So this telling us that what happens when it is greater than 2, equals to 2, and less than 2, and these 2 come from your denominator here. So let's talk about what happens when x is greater than 2. So can someone give me a number that is greater than 2? Anyone knows a number greater than 2 here? 5. Okay, we'll pick 5. Good. So we're gonna pick 5 in this case. And we're going to put into this equation here. So absolute value of 5 minus 2, and then divided by 5 minus 2. So you notice that 5 minus 2 is 3, and absolute value of 3, you still get 3. And then 5 minus 2 is also 3. So you find out that this is equals to 1. So you notice that no matter what number you put in, you always will get 1. Okay, so no matter what x that has to be greater than 2, you plug it in there, you find out that your answer is always 1. So it doesn't matter is 5, 6,000 millions, you still get 1. So this is 1 here. Okay. Next, we had to figure out a number that is equals to 2. So what happens when you put exactly 2 in there? So you find out that absolute value of 2 minus 2 divided by 2 minus 2. You notice that this is actually 0 over by 0. So that's why this is called undefined. This is called undefined here. So so this case you have to undefined. Sorry, my spelling. It all have to be capped, so you can figure out that, make sure that your spelling is correct, and I all have to be capped here. And then lastly, pick x is less than 2. So for x is less than 2, we will pick 1 or 0. Any number that is less than 2 and plug it into this equation. 0 minus 2 absolute value over by 0 minus 2 in your denominator. So you notice that for this case, 0 minus 2 is negative 2. But if you take an absolute value of -2, you will get 2 here. But your denominator, 0 minus 2, is -2. And 2 over by -2 is -1. So you notice that when you guys have, no matter what x value that is less than 2, your answer in this case is always -1. Okay. So this is how you get your answer here as a -1. So this is how we do this question number 17. That is a lot of students will have difficulty understanding this. So make sure this is how you do this. Do you guys okay with these questions? Anyone have any questions for me that I can go? Can you go over 27? Yes, I can go over question 20. Yep, if you don't want to talk, you can always type it in. So that's how we do question 17 and 27. Oh, I just passed 27. It's right over here. So this question number 27 is asking us, Sally, is this the correct question that you're asking, right? I think so. Okay. So identify the rules. So is that multiplication? Is that, so let's see what we have here. 1 over 5 times 16. So what they do here is they change the 5 times 16. Instead of multiply 5 times 16, they change to 1 over 5 times 5. So this is actually what we call as associative property of multiplication. So the first one that you guys see here, changing from 1 to the second expression here, is what we call as an associative property of multiplication. And then we know 1/5 times 5 is equals to 1. If I'm not mistaken, I think that is, I'll show it to you. Where was my P1? There you go. So we have all these rules here that you guys, hope you guys still remember this. Again, I won't come out these questions in your test, okay? So let me just, so you guys can see this clearly. So this changing the parentheses from 516 to 155 is what we call as the associative property of multiplication, where we interchange our parentheses. And then, so that's why we got that. And then 15 times, 1/5 times 5, that is kind of what we call as a multiplicative inverse property, where you multiply a number by inverse, you get 1. So that's why this, if you multiply by the inverse, you get 1. So we call it as multiplicative inverse property. And then as you guys know, that 1 times 16, you get 16. So that 1 that we have here, because you're multiplying with 1, so anything multiplied by 1, you get back the same thing. So this is called a multiplicative identity property. So this is multiplicative identity. So this actually has three rules here. So one, you change the parentheses, associative property, and then the other one is the fraction. If you multiply 5 and 1/5, you get 1. That is called the inverse property. And then 1 times 16, you get 16. 1 times will give you the identity. So this is how we do this question on number 27.
I think I took all 3 of those and it still would not accept it that it was correct.
Can you send me an email?
Yeah.
Just ask your teacher and I can take a look at it. Make sure it's multiplication, not addition. Maybe your answer might be a little bit, your question might be a bit off than mine. So send me an email, then I can look at it.
Okay.
Just click right over here, ask your teacher, and then I will look at what you got. Okay. All right. Anyone has any questions beside this P1 here before we continue with P2? Okay. Yeah, please, if you have any questions, you can always ask me. If you're shy, you can always ask me later on, which is fine with me too. Okay. So what we're going to talk about here is P2 here. This is called the exponents and radicals. So a lot of you guys know what is an exponent is. Exponent is where you got a number and then you make it to the power. Sometimes we call it the power. So a to the power of n is where you do a times a times a times a n times. So we call that as an exponent. A is called the base, and the n is called the power. These are the properties of exponents. This is also found in your textbook on page 14. So we have a lot of properties here. Yes, some of you ask me, do you need to memorize the property? I will always tell my students, do not memorize formulas, because it's some of them is that you just memorize your dictionary. So mostly in this class, we want you to know how to apply it. Okay, when do you apply it and know how to apply it? So the first property is if you multiply with the same base with the different exponents, you add them. And this one is very important. And I want to tell you that this is not just for my class. So if you are going to like college algebra and trigonometry and calculus, you still have to know all these properties like a basic property. So this property, I put a checkpoint, means you need to know this property. Again, don't memorize it. Make sure you know how to apply it. Okay. If you divide, they have to have exactly the same base. When you divide, you have to subtract it. The next one is very important, is if you have a negative, your exponents, it is actually 1 over a to the power of n. This is very important. This is used a lot when you have a negative exponents. So a negative exponent does not make the number negative, you make the number smaller. Once you put 1 over it, the number gets smaller, like fractions. So I want to tell you that this is important. The other one showing you here is not too important. 1 over a to the negative n means that, in other words, I can tell you that if your negative is in your denominator, you can always move it up to your numerator. So in other words, I can point out to you here is that if you have a negative exponents, you just flip-flop your denominator with the numerator. So what do I mean by that is that if you have a negative exponents on the numerator on top, you bring it down. If you have it on the down, the negative, you just bring it up. And when you flip-flop them, the sign will become positive. So you will change the sign from negative to positive. So this is usually what we do a lot in this class is if you see a negative exponents, just flip-flop them. Okay. Anything to the power of 0 is 1. I just want to point out to you that they have, like this case, x to the 3, y squared plus 9, all whole thing power of 0 is 1. Make sure you guys know that this is all whole thing to the power of 0. So what happens if there's no parentheses on this case? So you have x to the power of 3, y to the power of 2 plus 9 to the power of 0. So what happens if, let's say that the parentheses is no longer there and you just put a 0 next to this 9. So just the 9 and the 0 will become 1. So your answer in this case is not 1 like what we have there. Your answer in this case is x to the 3rd y squared plus 1. So the 9 to the power of 0 become 1. So just want to emphasize on the parentheses here, because a lot of students think, oh, David says anything to the power of 0 is 1. It's not necessary. If it's all inside this parentheses, then it's under 1 is 1, but otherwise you only affect the 9 and the zeros. Does one get what I'm trying to say here? Next is what we call as the kind of like a distributive property. So you have ab to the power of m. This m is distribute to the base a and the base b. So you got am and bm. And then if you have a power to the power, we multiply them. If you have, this is multiplication, this is division. So you have a over b to the power of m. Again, the m can be distributed to am over bm. So do not forget that these two, the distributive property that you see here can only work for multiply and divide. So what do I mean here is if you have addition or subtraction to the power of m, you cannot distribute this to become am plus bm. This is wrong. Okay, this is wrong. So do not do it when you have addition or subtraction. You can only distribute when you have multiply or divide. Okay. When you have an absolute value of a squared, you can actually take out the a become positive, become a squared in this case. So the last rule is really much not too important here, because you will learn this in your calculus class, where you just, if you have an absolute value of a square, they just tend to become a positive number. That's what it's telling us. Okay. Next is a scientific notation. A scientific notation is where you have a form of plus minus c times 10 to the power of n. A c in this case is a number between 1 to 10. 1 is included, 10 is not included, and n in this case has to be integer. So scientific notation is used a lot, especially in your chemistry class or your physics class. This represents really, really big number or really, really, really small number. So if your n is a positive number, the more bigger the n, the integer is, the numbers get bigger. If your n is a negative integer, like a -3, -4, means the number is getting really, really small. It's like 0.000 something. So we're gonna do some examples on these properties, then we'll the exponents, and then we do the radicals later on. So so we'll look at the radicals later on. Yep, this is much. Yep. So we'll talk more about this. So the first few examples is written down here that if you look at evaluate this question 1, A and B, if you look at these two, the difference here is between here is one has a parenthesis and one does not have a parenthesis. So for this case that doesn't have a parenthesis, the power 4 only affect the 3. So this is actually is -3 times 3 times 3 times 3. So this is -81. So if you do not have a parenthesis, the negative kind of like carry forward. Okay. What happens if you have a parenthesis? Then you have a -3 times -3 times. You do it 4 times because the power is 4. Since we have 4 negative, that become positive. So this is positive 81. Or in this case, you can just ignore it. The positive, you just put 81. Okay. So just be careful with parentheses and no parentheses. If you want to put this in your calculator, like question A, you don't put parentheses on it, but question B, you have to put parentheses on it. So if you use your calculator, make sure you guys know that parentheses are very important here. Next, question C, because the base is the same. So what do we do is we add your powers. So we got 3. And then your power in this case is 2 plus 1. Don't forget that if the number here doesn't have a number, it's always a 1 here. And then 2 plus 1 is the power 3. So 3 to the power of 3 is 27. For this case, is a division. So for division, we have to subtract. So when you subtract, you always subtract the top one from the bottom one. Okay. So make sure you guys know it's not always the biggest minus the smallest. It's the top minus the bottom one. So this 5 take away 8, you get a -3. And this negative is a negative exponent. So you put 1 over it. And then the 3 to the power of 3 is 27. So you get 1 over 27. So this is how we do this kind of questions for question 1. Next is evaluate. So when you evaluate x is 4, you can plug 4 inside here. So again, this negative that you see is just a negative. You just carry forward. But a negative exponents, you have to put 1 over it. So this is actually is negative 1 over 4 square. And 4 square is 16. So it's actually is 1 over 16 with a negative sign on it. This is when if you evaluate something, if your number is a positive number like 4 here, you don't need a parenthesis. But what happens when you evaluate with a -4, in this case, a negative number, then you need to put a parenthesis on it. So does anyone know what to do if I want you to evaluate when x is -4 in this case instead of 4? 4 is easy, but -4 is tough. So which one should we perform first? Anyone know what to do first on this question? If I changed from 4 to -4. Anyone know what to do? Should we change this to negative to become positive? Because you guys learned that a lot, right? To negative become positive. So can you do that? Yep. Delvin says distribute the negative one. That means these two negative become positive. Some of you will say, so this is come 4 to the, because two negative become positive, 4 to the power of negative 2. Is this the correct way to do it? The answer is wrong. So do not change these two negative or distribute the negative one to that. The reason why you cannot do this is wrong, is because orders of operation. So when you do PEMDAS, this is considered multiplication and this is considered exponents. So PEMDAS says exponents come first than the multiplication. So do not distribute these two negative. This is wrong. So the correct way to do this is you just take the negative and then you take 1 over negative 4 whole thing square. Okay. So what happened is I'm performing this negative first, and this negative is actually 1 over, and then this negative 4 in there, and the negative 2 become positive 2. If a negative 4, if you square it, this is 16. So you will get actually a negative 1 over 16. So you find out that the answer is actually the same. Okay. You find out that the answer here is the same here. So that's the reason why that just be careful with the negative here. This is the correct way to do this. Next, we will use a distributive property. So this question is asking us to multiply, because there's 2 parentheses here. So 2 times negative 1, you get negative 2. You find out that the x's that I boxed it out, you have to add your exponents, because since you multiply. So negative 2 plus 4 will give us a 2. And then for your y variables, you just take 3 plus 1, because you have power 3 and power 1 here, which give us 4. And do not forget that this is your answer. Do not forget that if your answer has any negative exponents, you have to put it in the denominator. For example, let's say if you have negative 2x squared with y to the power of negative, let's say you get y to the negative 4 here. So what happened is that this y to the negative 4 has to be put in the denominator. So the top, you still get the negative 2x squared, but then the denominator will become y to the power 4. So this is the answer I will accept. I won't accept anything if you have a negative in there, okay, on your exponents. You won't get the full points in this case in your test. So make sure you guys know, also in your online homework, they will mark you wrong. So make sure that you change all your negative exponents to positive by, if they're top, move them to the bottom. If they're in the bottom, move them back in the top. Question B is easy because everything here is power 0. So your answer in this case is 1. Okay. Question C, we have to add, first thing is we have to do the power 3 here. So in this case, we kind of distribute. So when you distribute, this is the part that you need to know is you need a parenthesis for the negative 5. So if you don't put a parenthesis on negative 5, you will get it wrong. So you have to parenthesize the negative 5 to the power of 3, z to the power of 3, and then z to the 2. Negative 5 to the power of 3 is negative 125, and then you need to add the exponents, so you get z5 in this case. Okay. D, this is even more difficult. I just want to point out to you that like question D, there are multiple ways to do your work, but your answer is going to be the same. Okay. So for me, the first thing is I distribute the 2 inside here. So this I have to distribute 4 times. And the reason why I have to distribute 4 times is because there are 4 kind of like a term, 4 variables, 2 on top and 2 on the bottom. So the 3 you will get square, the x I will get 8. The reason I get 8 is because 4 times 2 will give us 8. The x is 4 because 2 times 2 is 4, and y is 4. 2 times 2 is 4. And if you find out that I circle the x up, the reason why I circle the x up is because they are the same variable x. And when you divide, you can subtract it. So 8 take away 4, you get 4. So you put it on top. So you get 9x squared to the y 4. What happens if this came out to be negative? So instead of 8 minus 4, let's say you get 4 minus 8. Then you will get a negative 4. And since it's a negative 4, then this number has to go on the bottom. Okay. So for example, let's say you get something like this. 9x to the power of 4, and then divided by x to the power of 8, y4. So you find out that this x4 divided by x8 you can subtract. So 4 minus 8, you get a negative 4. And so what happens in this case is that you will get a 9 here over by x to the power of 4, y to the power of 4. So you notice that when you guys do this, if this is positive, you put it on top. If you find the subtraction here is a negative, then you put it on the bottom. Okay, but your 9 still remain the top. The reason why is because the 3 square is 9. Okay. You guys following so far with this exponents? This is kind of a review. Some of you already know this, but these are something that that we need to emphasize on. Yep. Yes. Okay. Good. Next, we will talk about here is rewrite it in a positive exponent. So this is, so as I told you, if you have -2, you can make it over a2. The 2 is still on top. So we just want to change this to become a positive exponent. Question B, this is a bit tough here. The reason why is because it has a lot of, you have to reduce this. So first thing, and 3 over 15. 3 over 15 can be reduced, become 1/5 by reducing by 3. And then if you look at your A, we have a to the -3 and a1 here. So we will subtracting this. Again, top minus bottom, -3 minus 1, you get -4. So when you have a -4, again, where we put it? Anyone know where should we put this a to the -4 at? Should we put it on the top or should we put it on the bottom? Yep, we put it on the bottom. So that's the reason why you notice that when you guys do this, you find out that the A4 here is on the bottom. Okay. And then we do the B. So we got B4 and B -1. Again, when we subtract, we got 4 times 4 minus -1. Again, this one is 2 double negative because we can make it positive. So that's why you get B5. And this time the B5 will put it on the top. Okay. So because it is positive, we put it on the top. The negative we put in the bottom. The 5 because of the reducing. Because 3 over 15 is 1/5, not 5 over 1. So that's why the 5 is in the denominator. Okay. Next thing is, if you have the whole thing power to the -1, so this, if you see the whole thing power -1, it means that you just, the negative here means you just need to flip-flop. There you go. So when you have a negative exponents, what you need to do here is you just need to flip-flop the denominator and change the sign to positive. So if this is negative, x over 10 become 10 over x, you flip it, and then the whole thing power 1. So this is what you do when you have a parenthesis and a negative exponents, you just flip-flop it. Okay. Question D, the first thing we do on this is distribute the 3. So the parenthesis of -2, 3x6, because 2 times 3 is 6. Now this one, because it has a -1, I put it in the denominator. Okay, I put this whole thing in the denominator because this whole thing has a -1. So that means it goes down to the bottom. And then negative to the power of 3 is -8 because it's -2 times -2 times -2 3 times. And then x6 and the same, I just rewrite the rest of it. So -8 divided by 4 is -2. And for this case, we will subtract 6 minus 3. So that's why you get a 3 in this case. Okay, so your answer in this case will be -2x cubed. You guys okay so far? Is this hard or is this all right? I know some of you, this is kind of a revision for you guys. Okay. We'll talk about scientific notation. So how do you write 45,850 in scientific notation? Is you move your decimal place. Your decimal place starts from here and you move here. So you kind of do that like a little hump, like little bump, 1, 2, 3, 4. So this one you move 4 to your left. So this will be 4.585 times 10 to the 4. So your decimals is always going to be on the first 2 digits. Some of you ask me, where should I put my decimals? If you're going to put in scientific notation, it's always the first 2 digits, and then you count how many hops or how many bumps you have to make. In this case is 4, so you make 10 to, that's why the 4 came up here. Okay. For this case, a -3, that means this number is going to be very small. So to change the decimal notation, you move this 3 times to the left. Every time when you make a little hop, a little bump, you have to insert a 0 in here. So it's going to be 0.002718. The negative is still negative. So again, I told you this negative exponents has nothing to do with your negative numbers. Okay. If you are in a nursing school, I don't know who you are, but if you are going for your nursing school, please do not write something like this in your nursing school. You will get yelled by your doctor. Okay. For nursing people, if you're going for nursing school, please make sure you put a 0 right in front of your decimals. For the rest of you guys, yes, you can just ignore the 0 in front of your decimals. But those who are going for nursing, make sure you put a 0 here. Okay. You know who you are. So make sure you guys do that. How are we gonna multiply such number without a calculator? I know some of you are like, okay, I can take out my calculator. I don't know how many calculators can put so many zeros in here. But what we do first is we just change all this into scientific notation. So again, for this, you put the decimal here, and then you count how many little bumps you have to jump from n to this between 2 and 4 here, the decimals. And this is actually there are 10. So you actually jump 10 times. So this is actually 2.5 times 10 to the 10. And then this, you need to figure out, you need to count backwards. And in this case, your decimals has to be in between 1 and 2. This is actually, if you count how many jumps you have, this is actually 7. The reason why it's a -7 is because you go to the right. And then lastly, the last one is your decimal has to be between 3 and 0. So you count how many jumps we have, and this one we have a 5 jump. So that means you get all these numbers in the scientific notation. And next thing what we do here is you take all these numbers and you multiply. So take out your calculator and then multiply 2.4 times 1.2 times 3. And if you multiply all this number, you should get 8.64. Okay. And then what happens to your exponents since you're multiplying? So we have to add. So you will add 10 minus 7 plus 5. And 10 minus 7 plus 5, you get 8. So that's why my answer in this case is 8.64 times 10 to the power of 8. Okay. So this is all what we call as exponents. Does anyone have any questions before we go on with radicals or roots? Radicals, the same thing as roots, which is down there. You guys doing okay so far with exponents? Okay. So now we're talking about radicals. So radicals is, if you hear radicals in math, means it's roots. So we have a lot of different types of roots: cube roots, square roots, fourth root, and so on. Square root means that the number has to be a kind of like a perfect square or 2 equal factors. Some of you know some square roots, like 4 is the square root of 2. No. Square root of 4 is 2, sorry. Square root of 4 is 2, square root of 9 is 3. So the reason why is because you multiply that number twice, same time, twice, you get that. Cube root is the same thing as square root, but instead of twice, you multiply the number 3 times. So like cube root of 8 is 2, because 2 times 2 times 2 is 8. Then cube root of 27 is 3, because 3 times 3 times 3 is 27. And then we have an nth root in this case. Nth root in this case, where this n is called the index. So it can be any numbers we want, and we don't have 1. So if you don't write any numbers, it starts at 2, and then 3, and then 4 and 5, and it's not division. So don't think this is a division. And then the number that is inside the square root is called a radicand. So so this is called an index, and that's called a radicand. And for those students who have sloppy handwritings, just be careful with this. Like if you want to write x to the power of 4 cube root of something, make sure that the 4 is on the top and the 3, the cube root for the 3 is kind of like a small little 3 next to the cube root. Because, and then try to leave some space in between this. The reason why is because if you try to put this close to each other, it will look like x4, 44, 3, and then a root. So it's kind of really weird. So usually I put some space around it so we can see that actually this is the power and this is the index for the roots. Okay. So for I think you guys very familiar with square root and cube root. So we will talk about that. This also there's a radicand and an index. So we'll talk about more about what happens if they are negative or positive in this case. So so if you have if your real number is a means a number. If you have n is even, then you will always get a positive. Okay. What I can tell you here is a cannot be negative. Just want to point out to you guys, this make your life easier. So if you have a square of 64 is 81, it's 8, okay? But what happens if you have a square root of negative 64? Anyone know what is this one going to be if you have a square root of negative 64? Anyone? 64 is square root of 64 is 8, but anyone know what's happened when you put a negative in front of in the radicand? Yes, this is undefined. You are correct in this case, Zach. This is undefined. Later on in the last section, I think P6, we will call this as your complex. Means this is the I form. Some of you will say, oh, this is the I. Yes, this will be the I form, the complex form. Okay. What happens if I put a negative in front of your square root? So now instead of the negative inside the square root, now the negative outside the square root. So negative square root of 64. So you think this will become undefined, or this is a number, a defined number? So what do you guys think about that if you have a negative in front of it? Inverse? Nope, it's not inverse. So is that undefined or is that a number? You have a number in this case. So I just put a negative in front of, for example, I just put a negative in front of this. So what happens when you put a negative in front of this? Then this will become a negative 8. Okay. So so the 8 here will become a negative 8. Now this is only work for square roots or even roots. So when I say even root means square root, 4th root, 6th root, 8th root, 10th root, you will get undefined when you have a negative number inside. What happens when you have a cube root? Now we know that cube root of 64 is 4. So what happens when you have a cube root of negative 64? So you think this will be undefined as the square root property that you have? Or is a defined answer? That means you have a solution. You want to know what happens when you put a negative in front of this 64 here? What do you guys think? Is that undefined, or do we have an answer? Yes. Zach is correct. This number is still stay at negative 4. So when you have a cube root of negative 64, this stays at negative 4 in this case. Okay. What happens if I take this cube root, this negative, and put it in front? Negative cube root of 64. You still get what? A negative 4. So if you put a negative in front or negative inside for cube roots, then you will still get a negative 4. And this is only work for odd roots. Okay, some of you was asking. So this is for even roots that we talk about. This is for odd roots. So cube root, 5th root, 7th root, 9th root has that property. Okay. What happens if it's a 0? I don't care if you have a cube root or a square root or whatever root you want for a 0. Your answer is always 0. Okay. So I don't care. This is the last thing they mentioned here. So they don't care whatever cube root, square root, 4th root, or 10th root of 0. You still get 0. Okay. And these are your perfect squares that we just did. And I just circled the 64 because if you count from the beginning to the end, 64 is the 8th one. So that's why the square root of 64 is 8. And for cube root, you got 64. If you count from beginning, 1, 2, 3, and 4. So that's why this is 4 in this case. So this is what we call as perfect square and perfect cubes, which is quite important. Okay. Lastly, we will talk about here is the property of radicals. This is also very important. So if you have if you want to do the power, the a to power of m first, and then take the nth root, you actually can do the nth root first, then to the power of m. This is used when you don't have a calculator. So we use this a lot when you don't have a calculator. The reason why is because that if you take the power of the number is very big. And then when you try to take a root of it, it's very difficult. So why don't we just take a root of a number which is getting smaller, and then we make it power bigger. For example is nth root of 82, 8 square. So you do the 8 square is 64, and then nth, the third root of 64 is 4. But the good news is 64 is a small number. So the better way that we use, as I put a checkpoint here, is you take the cube root first, and then you square it. So cube of 8 is 2, because 2, 2, 2 is 2, and then you square it, become 4. So this is the way that I will suggest you guys to do, because it will make your number smaller, and then after that you power it, which is easy to do. Okay, so just want to point out to you that you can do either way, but I would strongly suggest you do this. As long as the next property, as long as they have the same index, if you are multiplying, you can actually multiply them together, stick them together. So an example is root 3 times root 5 is the root of 15. Okay. Same thing happens when they divide. So if they are on the same, must have the same index, then you divide this number. So like root 10 over root 15 is the same thing as root 2 over 3, because I reduced this by 5. Also the same thing as root 2 over 3. I just want to point out to that this two property can only do for multiplication and also division. Okay. It will not use for addition or subtraction. You cannot use it. Okay. So you cannot say that root 3 plus root 5 is root 8. Okay. Oh yeah, square root of 3. If I change it to positive, a lot of students will do what? Oh, 3 plus 5, 8, right? So this is square root of 8. No, you cannot do that. Okay. What happens when you have a root 3 plus root 5? Your answer will be root 3 plus root 5. You cannot reduce anymore. Okay. Same thing happens if this is a minus. So root 3 minus root 5, cannot subtract it. Your answer is just root 3 minus root 5. So make sure you guys know that this property can only use for multiply and divide. What happens when you have multiple roots? It's very easy. You take the index and you multiply it together. So you put 1 and then multiply. For example, a cube root and a square root of a. So what you do is 3 times 2 is 6. So this is a 6th root of a. Okay. If your power and your root index are exactly the same, so you can actually cancel them out, that become just a. Example is a cube root and a power of 3. This 3 and this will cancel. You get 10 here. So what happens if you have, this is what happens when you have the whole thing power of n. And what happens if n is inside the radical here? Then if it's even, you get an absolute value of a. But if it's odd, you get a here. This is used in your calculus class. So that's the reason why that if you are going to calculus class, these two last property used a lot in your calculus class. Calculus 1 and 2 mostly. So when you simplify radicals, first is all possible, you have to factor have been removed from the radicals. And then for examples like square of 50, so you had to figure out what is the factor of 50, what times what is 50, that one of these is a perfect roots. So we use 25 and 2, and then 25, we can pull it out, become 5 root 2, okay? If it's for variables, yep, questions? Is the answer inside the D? if the exponents inside the D, what do you mean by D in this case, Zach? Can you talk, Zach? Inside the D root. Zach, can you talk?
Can you hear me?
Mhm.
I didn't mean to spell the D. I was curious. So if an exponent inside the root is larger than that of the exponent attached to the root, or the
Doesn't matter.
no?
Nope.
I was just curious because
so you're talking about if this is a square root of 8, square root of 4, let's say 16 to the power of, let's say 5, right?
Yep.
So the square root is smaller too. The index is smaller, right?
Yep.
And 5. So what you do is I prefer you to do the square of 16 first. So that will become 4, and then you make it to the power of 5. This one is a big number, like 4 times.
Right.
Then you take your calculator and multiply 4 times 4 times 4, like 5 times.
Okay.
Yep.
Thank you.
So it doesn't. So this doesn't mean that this number, the index has to be bigger than the power. It can be the other way around. Okay. So no. Oops. Sorry. Oops. Wrong button. Okay. So what happens if you have variables? This is numbers that we did just now, a variable. So for variables, if you have variable like 10 here, then a cube root in this case, you have to find a power that is very close to this 10. So in this case, will be 9. Why is 9? Is because 9 is a perfect square of cube. And how do we know if a variable is perfect square? It divides evenly. Okay, so 9 divided evenly to the 3. So that's why it's a perfect cube. Okay, then you get a 1. The reason why we get a 1 here is because when you add these two, you get 10. So 9 plus 1, you get 10. And this A9 is a perfect cube of A3 because 9 divided by 3 is 3. And then the A1 still remain inside the radical. So this is how we simplify radicals with numbers and variables. So make sure you guys understand this is very important because the P2, the second part here, is the most important part. And then make sure that when you add or subtract, there has to be the right radicals. Right radicals means they have to have same index and same radicand. So like example is cube root of 10 plus cube root of 10. Then you can add this one up. So these are like radicals, and you will get 2 cube root of 10. This is exactly like x plus x. So some of you was asking, how do you think about this? Because this is the same x, this is the same x. So x plus x we know is 2x, right? So this is the same thing. Cube root of 10 plus cube root of 10 is 2 cube root of 10. Okay. So this is a part that you guys need to know. This is called the like radicals. Okay, and you can only add them. Rationalizing the denominator. So to rationalize the denominator, if you have two terms like what we have, like this 2 plus root 3, then you have to do what we call as the conjugate. The conjugate in this case is 2 minus root 3, and you have to multiply them, the top and the bottom part. Okay, and then if you have just one term, this is called a one term. Square root of 2, then how do we rationalize the denominator? We just square it on both sides. This 2 depends on your denominator. So if this denominator is 5, then you multiply by square root of 5. So root 2 times root 2 is 2. So this is something I want to point out to you. Square root of a, if you multiply it with the same square root of a, you will just get a. Okay. So this is one of the important square root rules here is if you multiply by itself, the square root will cancel each other off. It's like squaring it, okay? So 3 times 2 is root 6 in this case. And this is lastly, the most important part here. This is very important, is changing roots to exponents. Yes, we can change all your roots to become exponents. For example, is if you have a to the power of m over n, m in this case is your power, n in this case is your index. For example, if you have 4 to the power of 3 over 2, this 2 is your square root, and this 3 is your cube root. So make sure you guys know that the top one is always your power, the bottom one is your index, the square. Okay, so and then square of 4 is 2, and then cube it is 8. So I just want to point out to you that a to the power of 1/2 is square root of a. A to the power of 1/3 is a cube root of a. So the number underneath here is your index. So this is how we change from exponents to radicals, and then radicals back to exponents backward. No, it goes 2 ways. Okay, this used a lot in college algebra. So when you're going for college algebra next semester, we use this a lot. Okay, so make sure you guys know once you see a fraction, it's a radical, it's a square root or cube root. Okay. All right, so let's talk about some examples here. We got like 15 minutes here. So these are pretty much we talk about. So you just number 8, you can just go through it. This one is easy because you just divide, you get 25. This B is a tough one, but talk about the B. So the 8 is easy. I think you guys can figure out. So 9B, cube root of 125 squared. This is the one I told you that if you take out your calculator and do 125 square, 125 square is a very big number. How big is it? Let me see. 125 square is 15,000. So you're going to do a cube root of 15,625. So this is what happens that, and then this is cube root of that number is difficult. Actually, it's 25 if you have a calculator. But what I suggest is do not do the square first. I suggest you do the root first. So do the cube root of 125 first, and then you square it. And cube root of 125 is 5. And then when you square 5 is 25. So this is so much easier than doing square it first and then root it. Okay. So this is really strongly what I suggest you to do. Okay. For this question, since they are having exactly the same index and the power, the variable is the same, so we can add this like what we just did in exponents. So 2 plus 1 is 3, and cube root of 3 and 3 become x1. Okay. This one we talk about it if you have square root and square root. So if you have double square root, if their indexes are 2, so you just multiply them. Okay, you just need to multiply it. So that's why you get 2 times 2, which is 4, 4th root of x. Okay. So it's pretty much straightforward type. Simplifying this, this is now going to go more difficult. So 32, so you have to find a perfect square that goes to 32. A factor of it is 16. So 16 times 2 is 32, and 16 is a perfect square of 4. So that's why it's 4 root 2. Okay. So in your test, if you give me your answer as root 32, I will not mark you right. Okay. 4 root 2 is the one that I'm asking you to do. Okay. All right. So I want you guys now. Can you guys taking attendance here? So can you guys go ahead and type in present, including Sanford? I know you did earlier. Can you guys go ahead and type in present for me? Thank you so much. Go ahead and spend some. Yep. Perfect. Perfect. Keep on doing it. Only one time. Don't do it too many, except for Stanford. Yep. Thank you. Yep. Go ahead. Type in present. Taking your attendance now. This is the easiest way to take attendance, as I keep everything. Okay. So make sure you guys do it. You got like another 10 more minutes, something like that. So make sure if you haven't done present, please make sure you type in present, taking attendance. All right, next question B is, this is a cube root of 250. So a lot of students do not see the cube root and they use the perfect square here. This is the most, a lot of students make mistake in my class when they do this, is they use perfect square. Oh, I'm gonna use 25 times 10 because 25 is a perfect square of 5. So I will put this as 5 square root of 10, and you will get wrong here. Why you will get wrong here is the reason why is because this is not a square root, this is a cube root. So so this will be considered wrong. So a lot of students who who watched carefully with the index here. So the 250, we will use 125 times 2 because 125 is a perfect cube of 5. So you get 5 cube root of 2. For question C, we'll break, if you see a variables and numbers like this, we'll break it out. So numbers, you do it, and then variables, you do it on the side, and after that, you combine them together. So 24 is 4 times 6. So if you do the factor, 4 is a perfect square of 2. A4 is a divisible by 2. So 4 divided by 2 is A2. So you find out that this 2A2 will be outside. And what is left inside the radicand is the 6 that we have left over. Okay. For D, if you have a negative, it's a cube root. So it's not a no solution type because cube root can have a negative. So again, I break it down into variables and numbers here. 135 is 27 times 5 with a negative. Then this negative 27 is a perfect cube of negative 3. X cube is a perfect cube of x. So we combine this back together, you will get negative 3x and then a cube root of 5 in this case. Okay. So that is how we do simplifying this. So next is adding. So these two are not like radicals. So what you do is you can break it down. So 8 is 4 times 2. 4 is a perfect square of 2. And then 3 times 2 is 6. So you get 6 root 2. 18 is 9 times 2. And 9 is a perfect square of 3. So you get 3 root 2. Now these two are having like radicals because they all have root 2. So you just add the number in front, 6 plus 3, which is 9 root 2. Okay. Same thing happens to question B, which is more difficult because there are cube root here. So 81, cube root 81 is 27 times 3. So 27 is a perfect cube of 3. X5, cube root of X5, 5 is not a perfect cube. So we need to find a number that is kind of close to the 5, but it's perfect cube. So we use X3 and X2 because 3 plus 2 is 5. And this X3 is a perfect cube of X because it's a perfect cube. So in this case, the 3X will be outside. The inside is 3X squared, a cube root. And then we do the next one. This is tough, I tell you. 24X squared. 24 is 8 times 3. 8 is a perfect cube of 2. So this is 2 root 3. X squared, we cannot break it down because it's too small to divide by 3. So this one is done. So this is 2 and then cube root of 3x squared. And when you notice that, you find out that this cannot, although they have the same radical, okay, they all looks the same radicand here, same radical, but you cannot subtract 3x minus 2. So this is your answer in this case. However, if this 2 has an x on it, so it's exactly the same with 2x, then we can combine like terms here because 3x minus 2x is 1x. So when you have, if there's an x inside here, like what we did here on the blue ink here, then your answer will be x cube root of 3x squared. So far for this question, this is your answer in this case. Okay, so when you guys type this in your online homework, I just want to point out to you that your online homework, when you guys type in, it has a thing pop up on the side here. Okay, and this is where you do your cube root, this square root, but some of them might have a cube root. Maybe go under. So if you see me clicking on the side here, so those are the one that that you will have. Then you can use it. This is square root. But I think for that section, you will get a cube root a cube root button or fourth root button. There's a little 2 blank spot here. So I recommend this is how we type it. So when you guys click on it, please make sure on the corner right here, they will show you all this special stuff. Oh, that's a cube. I found it. There you go. That's a cube root. So this is a cube root. So you put a 3 in here, and then whatever number you're going to put it underneath that. Okay. So this is the cube root symbol that we have here. You guys following how you type your answer for cube root and square root in your homework here? Actually, it takes you longer time to type your work there. All right. Next, we'll talk about almost done here. Rationalizing. So when you rationalize this, If you see a square root of 2, you just multiply it by root 2. This is very straightforward. And then root 2 times root 2 is root 4. Root 4 is perfect square of 2. So 3 times 2 is 6. And then you got 5 root 2 on top. What happens when you have a cube root? A cube root, you have to make your denominator a perfect cube. So if you have a 5, 25 is a 5 square. So we multiply this with 5 to the power of 1. The reason why is because this 2 and 1 will make us a perfect, a 3, which is a perfect cube of a 3. So the 3 will cancel and become 5. So this is what happens when you have a perfect cube. You will try your best to make your power to become power 3 so that the 3 and 3 here will cancel. So this will give us 5 on the bottom. The top one is cube root of 5 in this case. And for part C, this is where you do the addition piece here. This is where you got 2 terms. So when you got 2 terms, you do your conjugate. You do your conjugate, okay? And root 6 minus root 2 is root 6 plus root 2, and you have to multiply your conjugate on both. And when you multiply conjugate, it's very easy. It's root 6 times root 6, you get 6. And then root 2 times negative and the positive root 2, you get 2, and you get 4 in this case. The top one, you will get 8 times root 6 plus root 2. I don't distribute the 8 first because the 8 and 4 can be reduced, become 2, and then I distribute it. So now you just distribute your 2. So your answer in this case is 2 root 6 plus 2 root 2. So this is the last, I don't think so I have enough time to go through the last page here. So make sure you guys we'll just go through this 13 really quickly and then we'll just end today's class. Make sure you finish up the rest of it. This question wants you to write exponents form. So if you have an index, you just need to write 1 over it. So like this one is 3, you just write 27 1 over 3 because your index is 3. This one, you just write everything to the half. So, but when you write everything to the half, you need your parentheses. So it'll be x3, y to the 5, and z, and then all of this to the power of 1/2. And then what do I do here is I take this 1/2 and I distribute it. So the 3 will become 3/2, the 5 will become 5/2, the 1 will become 1/2. So that's why you get this answer in this case. And the last one here is, this is 3x, and then this is x to the power of 2/3. The reason why this is 2/3 is because your power here is 2 and your index is 3. Now, a lot of students try to add this one up. You do not need to because this question just wants you to write this in the exponent form. If you want you to add, then the question will ask you to simplify here. So just leave your answer like this. You do not need to add the 1 and 2/3 here. Okay. The rest of this, I recommend you guys to go through it on your own. Especially number 15 here is a bit tough. So if you have any questions, especially when you do your homework, please let me know. Okay, I will post this online so you guys can the video so you can watch it. Does anyone here have any questions for me? You guys all type in present, right? I hope so for attendance. Otherwise, I'll mark you. Anyone have any questions before you guys go today? So don't forget your homework for this Monday is P1 and P2. So you got 2 homework that you have to do here. So make sure you guys spend some time doing P1 and P2 here. Anyone have any questions for me before we get going here? Anyone have any questions for me? I'm going to stop sharing here. All right. And I'm going to stop recording.